Hi, I'm Jason Schneider, and thanks for joining us for part 2.2. Now, last in part 2.1, we were talking about dispersion plots. Well, in 2.2, we're going to talk about searching with grep. That's grep with G-R-E-P, as you can see right here. So, let's go ahead and, well, before we do that, again, just to remind you that this is text analysis with R for students of literature, written by Matthew Jocker, and we are in chapter 4. And now we are going into searching with grep. And before we can do this, we need to run some code, some similar code that we had ran earlier, but we're going to run it again. But first, set your working directory. So there we go. I set my working directory. And I'm going to scan the novel. So this is, if you're kind of wondering the first 5 lines of code what I'm doing, please watch part 1 and part 2.1 in order to have a better and clearer idea of what is going on here. Okay, so here we have to identify the chapter break positions in the vector using the grep function. Grep is an R function for performing regular expression pattern matching. Using the regular expression, the caret chapter / d will allow grep to identify lines in the vector that begin. The start of the line is marked by the use of the caret symbol with the capitalized letters chapter followed by a space, and then any digit. These are digits that are represented using an escape D, as in / d. So we're going to run this, and this right here will be vital. Okay. Then we're going to run the next couple of lines here. So in this very last one, as you can see where we're concatenating 2 of these vectors. So we said where it begins and where it ends. We're talking about all chapters. So we set where the book begins chapter 1 to all the way to the very last page of the last chapter. A for loop allows us to do a task repetitively for a set number of iterations. In this case, the number of iterations will be equal to the number of chapters found in the text. You will need a place to store the results of the analysis during the for loop. For this, you will create 2 empty list objects. These will serve as containers in which to store the calculated result of each iteration. So right now, when we have list, the first one will be the number of each word's occurrence, and the second one, it will contain the frequency of each word's occurrence. But right now they're empty. Now, once I run this for function, this is a function right here, for, and it's made up of several ingredients. So we have an if function, that's one of the ingredients, and so on and so on, which we'll go over. So we'll initiate a loop that iterates over each item in chap.positions.v, basically this vector. And then after pertaining to running this if function, as long as the value of I is not equal to the length of the vector, R just keeps iterating over the vector. The function if allows us to set a condition that will evaluate to either true or false. If the condition is found to be true, then the code inside the curly braces of the if statement will be executed. This has the effect of saying, so long as this condition is met, continue iterating. The condition here is that I not being equal to the length of the vector. The reason I must set this condition is because there is no chapter text after the last item in the chap.positions.v vector. I do not want to keep the loop going once it gets to the end. Assuming that the condition stated in the if statement is met, I proceed to the next line. At this stage, the program captures the chapter title, which is found at the place in the novel .lines.v, indicated by the value held in the chap.positions.v. So we're going to take a look at this example here to kind of understand this better when we're looking at this I. So let's just say that I was equal to 1. Okay, well, then this vector, chat.positions.v, with the value of I, it would be chapter 1. And if we did, let's say, novel lines, and of course chap.positions.v being a column within novel lines, this vector, then we should get literally from the text chapter 1 loomings. Now, what if we had I set to 2? Well, then if we ran this, this would be chapter 2 starting on line 185. Line 185. So where we saw here in this first example, chapter 1 begins, of course, on line 1. But when we talk about chapter 2, it begins on line 185 of the text. So if we put in with line 185, if we were to put novel.lines.v, then with the column chap.positions.v, then we should see that, yes, line 185 says chapter 2, the carpet bag. Okay. So the title of the chapter is at the ith line in the novel lines.v. So I can add 1 to I and get the values of the next line in the vector. So I plus 1 will give me the position of the first line of the chapter text, excluding the chapter title. That's because if you have it 1 outside the brackets, this is talking about line numbers. If we have 1 inside the brackets with the I, then we're talking about chapter numbers. So if the 1 is outside of the brackets, this 1 represents lines. Therefore, if we add 1 outside the brackets, we are adding the starting position at 1 line later. That is after the line that says chapter such and such. What is done here is a bit more subtle. Instead of adding 1 to the value held in the ith position of chap.positions.v, I must add 1 to I in its capacity as an index. Instead of grabbing the value of the ith item in the vector, the program is going to grab the value of the item in the next position beyond I in the vector. So let's take a look at this example. And essentially what we're saying here is that if I were equal to 1 and we were to type the vector chap.positions.v.i, well, that would be line 1 of the very first chapter. But if we were to have here plus 1 to I, we would have chapter 2 starting on line 185. Now, if we add 1 inside the brackets, that means that we are at the next chapter. And if we minus 1 outside the brackets, we are going back 1 line. Remember, whatever is inside the brackets is the chapter starting at line 1 of that chapter. Whatever is outside the brackets, such as minus 1, is the line number, not the chapter. So here, when we're trying to create a vector that says end, and we have plus 1, but then minus 1. So here we're saying, okay, I want the end to go all the way to chapter 2, but we don't want the first line of chapter 2. We want the very last line of the previous chapter. So we minus 1 outside the brackets. Hopefully that kind of makes sense. At first, that might be hard to grasp, but once you kind of see what's going on inside the brackets and what's going on outside the brackets, it's not so bad. And so Again, we're not going to actually go over all of these lines that's in here. Why? Because in part 1 and part 2.1, part 1 we definitely went over some of this already. So review part 1 if you're if you're not sure or maybe don't remember everything that was discussed. With the start and end points defined, you grab the lines, paste them into a single block of text, lower case everything, and then split it all into a vector of words that is tabulated into a frequency count of each word type. Okay, so that's what all these are doing. And then we have this next ingredient here. So what we want to do is we'll create another one, chapter.raws.1, and then inside these brackets, the chapter title. And so this next line is where the resulting table of raw frequency counts is stuffed into the list that was created before entering the loop. The double bracketing here is used to assign a name or label to the list item. And here, each item in the list is named with the chapter heading extracted a few lines above. It is not necessary to assign labels to list items in this way. If you leave out the label, the list will just be created with numerical indexes. And then, of course, we end this function with a couple others. We want here, the last two lines simply convert the raw counts to relative frequencies based on the number of words in the chapter. This relative frequency table is then stuffed into the other list object that was created before entering the for loop. So let's go ahead and run this thing. It's actually quite quick too. There we go. Very fast. Okay. Now we're going to actually go into accessing and processing list items. Now that we've created lists. By adding the bracket as the function argument to lapply, you tell lapply to apply bracketed subsetting to each item in the list. Each item in the list is a table of word counts or frequencies. lapply allows us to add another optional argument to the function that is being called. In this case, the function is bracketed subsetting. And if you want to learn a little bit more about lapply or any other function, you just type the question mark in the function and it will actually go over it over here. So like for example, if we want to try this and just see what happens. And see, it'll actually give a description. It'll go over the usage and arguments. And this is really useful. So I recommend anytime you're unsure about some of these things, go ahead and type in a question mark right before the function and you can get some kind of idea. Now, this is actually a little harder to maybe grasp what R is doing. I am actually still kind of learning this as well, so don't feel alone. But when we have this bracket here, just as right here in this line of code, so we create a vector here, whale.1, and it's by using this function lapply, and we're going to use this bracket as an argument, and we're searching for optional things such as whale. Essentially what the argument is here is that these are each chapters. So chapter, like here, chapterfreaks.1, we could just type out these individually, but there's like 135 chapters here. That would take a long time. So the easier way to do this is just hit lapply, and we use this function here that R recognizes. So like I said, this is not exactly maybe up front, but this is a little shortcut that I'm still kind of grasping as well. But Matthew Jocker definitely suggests this, so we're going to go with it. Now we need to generate a new list of the whale values for each chapter. We want to find the occurrences of whale. Just to remind you, the columns in our data frame are chapters, and the rows consist of lines. That is, each line, we're talking about sentences and such, found in the book, in which we are finding where whale occurs. Okay, so we're going to actually run this. Okay, so then we got to use a do call function. Therefore, to activate the rbind function, so we're actually kind of using two functions here across the list of whale results. Doing this will generate a matrix object of 135 chapter rows by one column of relative frequency values for the word whale. A matrix object is like a very simple spreadsheet. A matrix has rows and columns. With this next line of code, we want the mean of whale for each chapter. So we're going to run that. Okay. And then we're going to do the same exact thing that we did for whales. We're going to do it for Ahab. Okay. The lines of code creates vectors for words whale and Ahab. So to kind of see an illustration, because we're talking vectors and matrix, here are a couple of illustrations here. So when we have a single type of vector, typically one column with several rows, that could be a vector. But when we have a matrix, you're going to have multiple rows or multiple columns. So you'd have like columns here, and then you'd have vectors here. An array is actually several matrices. So we could have many of those. Another illustration that might help here to visualize this, again, a vector, you got a matrix. And when we create list, we can list vectors, arrays, data frames, list. But when we talk about data frame, the difference between a data frame and a matrix is that the matrix, each column is necessary to when we look at the rows. Whereas a data frame, columns can be different modes. Hopefully that kind of gives you some kind of visualization. If you're still new to R, a lot of this might still be a little tough to grasp. I highly recommend in that case kind of work on some of the basics. But once you get past the basics, this visualization will come together better. Okay, so basically now what we're creating from doing the mean of the occurrences of whales, and also we want to find out the frequency of whales, we are creating vectors here. So I'm going to run that for whales and Ahabs. Okay. And once we do that, real quick, I want to double check something. Okay. So yes, so I'm just double checking, making sure that we're all right. You can now use cbind to bind these vectors into a new two-column matrix. The resulting matrix will have 135 rows and 2 columns. A fact you can check using the dim function. So I can kind of show you about dim, but first let's do a cbind. Okay, so now, and the dim function is kind of nice. There you go. So you can see the dimensions here. We have 2 columns here and 135 rows. Now reset the column names manually using call names function in conjunction with the C function. Basically, so we concatenated both of these vectors, but we need to name the columns. And then let's actually create a visualization here. And as we can see, kind of like the dispersion plot in 2.1, here we can actually see that we have a main concentration of whale right in the middle. But we look at Ahab, we actually see that right in the middle, Ahab does not occur so much, but instead occurs on the sides around the main concentration of whale. So wherever we have a main concentration of Ahab occurring in the text, we see the absence of whale. When we see the presence of whale, we're going to probably see an absence of Ahab. Now this next part, let's actually try some of the practice sets that Matthew Jocker has prepared for us in 4.1. And the purpose of this is that we want to write code that'll find the value for another word and then bind those values as a third column in the matrix. So we'll plot the results as in the example code. And as you can see, first let's get our whales together and our Ahabs. Okay, so now we got this new word, and we kind of want to see where this occurs. Okay, and we're going to bind, and then there we go. So as you can see, actually this part right here we can go back. Let's compare that. So as you can see right here, this kind of goes down. So when we go over here, this is where this third word comes in, and there's a major concentration of its occurrence at the very beginning of the novel, at the very beginning. So if you're kind of interested where these things are occurring, and you can then find some kind of distribution in order to begin talking about or speculating about a relationship among these things in the novel. Now let's take a look at the second practice set here. And in 4.2, these plots were derived from the list of relative frequency data. So we have to write a script to plot the raw occurrences of whale and Ahab per chapter, which isn't too bad. We can do that. And it's kind of the same thing. So here we got similar code, and it's actually just about the same. If you take a look here, it's exactly the same. In fact, I'm going to separate this so you can visualize it better. Okay. Okay. And then we actually see the raw counts. But you still kind of see right here that there's a main concentration right in the middle. But frequency counts, we get a clear idea where these things are occurring when we look at the frequency of occurrences. I hope that you enjoyed this. We will have part 3, and part 3 we'll begin talking about chapter 5, where we make correlations, and we'll see how to make these correlations of tokens and such from a novel. We've been talking about doing a token analysis in part 2.1 and part 2.2. And remember, each token, when we're talking about tokens, we're talking about words. And so doing a token analysis could corroborate some kind of whatever analysis you might be doing on a novel. I highly recommend you check out the other videos and visit our website at https://omega.uta.edu/squiggly symbol and JSS 7644. Again, thank you for watching, and I hope you join us next time.